Okay, in this video, I will show you what is type number control system. Type number of transfer function GHS indicate the number of poles in the origin that the transfer function has. Okay, transfer function is GHS. Okay, type number of transfer function GHS indicate the number of poles in the origin that the transfer function has. This can indicate whether the steady state error of the system will be 0 or constant or infinity according to the input. Okay, we have this transfer function. GHS is equal to K S plus Z1 S plus Z2 divided by Sn S plus P1 S plus P2, where K is a constant, Z1 and Z2 is 0, P1 and P2 is poles, N is the number of poles at origin. Okay, number of poles at origin. Okay, we can refer to the S-plane. Okay, in S-plane we have right hand plane and left hand plane and origin here. So number of N is indicate the number of pole here. If N equal to 1, means that number of pole here is 1. If N equal to 2, number of pole here is equal to 2. Okay, so let's study how to relate the system type and the number of the system type number and the steady state error of the system. So we can we want to know whether it's 0, constant or infinity. So let's start with n equal to 0. So when n equal to 0, we know that number of pole at origin is equal to system type number. Okay, number of pole at origin n is equal to system type number. Type number is n equal to 0, means that our system is type 0. Okay, and our transfer function will be K divided by S power of 0. So type 0, so F power 0, S plus P1, blah blah blah. Okay, so from here we can see that S power of 1 equal to F power 0 equal to 1. So it will become K over S plus P equal to K over S plus P1. So graphically it will be like this. E minus P1. Okay, T. Okay, so when T is approaching infinity, so our output will approaching 0. So final value equal to 0. So steady state error will become 0. Okay, this one is graphically. So we can also derive during using mathematically. From the previous lecture, okay, limit s goes to 0 s es. Okay. So now we can study final value theorem equal to limit s goes to 0 s times k over s plus P1. Okay, when s equal to 0 means that this one becomes 0. So f final value also equal to 0. Okay, agree. This is for type 1. So next we go for, sorry, this one is for type 0. For type 0, steady state error become a 0. Now we go to type 1. Type 1 means that S, okay, for transfer function, K over S power of 1, S plus P1. Right. Okay, we know that for K over S, our graph will be, start K here, T here. So when T goes to infinity, our final value will be K. So final value equal to K means that constant. So again, we can use final value theorem is equal to limit S approach to 0 S time K over S. So will be equal to slash will be equal to K. So final value equal to K, constant. Okay. For type number 2, transfer function will be K over S power of 2. Type number 2. So S plus P1. So from this equation, we can see that K over S power of 2 graph will be RAM. So T, when T approaches infinity, final value will become infinity too. Okay. So again, we can use final value theorem, limit S approaching 0, S time K over S power of 2. So this one we can cancel. So when S approaching 0, K over 0 will become K divided by 0 will become infinity. Okay, final value also become infinity. Yeah, I agree. Type number 3, just replace our transfer function equal to K over S power of 3. Okay, S power of 3. So n is number of pole at origin, S power of 3. Type number, type 3. So we use this standard equation. S plus P1. Okay, we know that K over S power of 3 will be like this. Acceleration graph. T equal to infinity. Our FV also equal to infinity. This one is graphical. In final value theorem, limit S approaching 0, S time K over S power of 3 will become 2 K over 0 will become infinity, FV. So this one is our steady state error for type number 3 is equal to infinity. Okay, so now we can conclude that